Hello. So today we will discuss about variation. Let me start with an example. If you work for an hourly wage of $10, then so we have two variable here. The one is number of hours and another one is pay. Then obviously if you work 1 hour, then you'll make $10, right? So if you work for 2 hours, you'll make $20. And if you work for 3 hours, you'll make $30. And if you work for, let's say, 5 hours, then you'll make $50, right? So what you can observe here, as the number of hours double, your pay is also double, right? And as the number of hours triples, your pay also triples. So that means as the number of hours increased, pay also increased, and as the number of hours decreased, pay also decreased. So that means these two quantities, pay and number of hours, they are in a direct variation. So let me write down the definition, okay guys? So why varies directly as x. So we also call y is directly proportional to x if there exists a non-zero real number k, also called constant of variation, such that for all x, y equals to kx. And you see that this y is equal to kx, this is a linear function. And this k is the slope. So if k is positive, as the value of x increase, the value of y also increase. As value of x decrease, the value of y also decrease. So that means these two quantities, they are in a direct variation. Okay. So the next is the definition for direct variation as nth power. Let n be a real number. This is exactly positive real number y, whereas directly is nth power of x if there exists a non-zero real number k such that for all x y equals to kx to the power n. So this is the definition for direct variation as nth power. So now here if we put n equal to 1, then this is exactly y equals to k times x. Okay? So this is the definition for the direct variation as nth power. So let us do one example. Okay? So let's say if this is the example, if x varies directly as y and x equals 10 when y equal 2, find x when y equal 7. So let me solve this problem. So if you look here, x varies directly as y. So that means from the definition of the direct variation, x equals ky, where k is the constant of variation. So you substitute the value of x equal to 10, and we know when x equal to 10, y equals 2, right? So you substitute the value of x equal to 10 here. This equal k times this y is 2. So this is equation 1, okay? So from here, you solve for k, divide both sides by 2, and that will give you k equals to y. Then you return back the value of k in equation 1, you'll have x equals 5y. So now you have to find out x when y equal to 7. When you plug in y equal to 7 in this equation, then you will get the value of x. Substitute y equal to 7 in x equals to 5y, right? So that will give you x equal to 5 times 7, which is what? 35. So the value of x is 35. Okay. So the next one is inverse variation as nth power. Inverse variation as nth power. let n be a positive real number. Okay, positive real number. Y there is inversely is nth power of x if for all x there exists a non-zero real number k such that y equals to k over x to the power n. So for if n equal to 1, so this is y equal to k over x, so that means y there is inversely, okay, so inversely x, okay. So let me do some example related to the inverse variation. Okay, so let me copy down the example here. If this is example, okay, if G varies inversely as W, and Z equals to 9 when W equal to 7, find Z when W equal to 3. So remember that y equals to k over x, that means y varies inversely as x. So now here G varies inversely as W, so that means Z equals k over W, right? So now let's say this is equation 1. So, but we have G equal 9 when W equal to 7, right? So you substitute Z equal 9 and W equals 7. So if you multiply both sides by 9, if you multiply both sides by 9, sorry, if you multiply both sides by 7, then you will have k equals to 63, right? So you substitute the value of k back in equation 1, so you substitute the value of k in equation 1, then we will get Z equal 63 over W. So now we got the variation equation, right? So but we have to find out Z when W equals to 3. So for that you substitute the value of W in this equation. Substitute W equals to 3 in G equal 63 over W. So it would be G equals 63 over 3, which is 21. Right? So the value of Z is 21 when W equal to 3. Okay? So let me do the last example. So the last example is, suppose R varies directly as the square of n. And inversely as S. If R equal 11 when M equal to 3 and S equal 1, find R when M equal to 6 and S equal to 1. Okay, so let me solve this problem. So you remember, if Y varies directly as nth power of x, so that means y equal kx to the power n, right? And if y varies inversely as x, then you'll have y equals to k over x. So we have to use these two concepts here. So R varies directly at the square of m. So that means R equal km square, right? And then it's inversely as s. So you have to put s on the bottom, okay, on the denominator. So now we have this equation here, and we are given if R equal 11, so you plug in 11 here, you substitute the value of R11, this equal K times, what is the value of M? So M is 3, so this is 3 square over, what is the value of S? 1, right? So from here you have to solve for K and then plug in back to the original equation, okay? So let's say this is your equation 1, okay? So this is your equation 1, and from here you solve for K, so 11 equals, so this is 9K, that will give me K, you divide both sides by 9, right? You divide both sides by 9, so that will give me K equals 11 over 9. So you plug in back the value of k in this equation. So you'll have r equal, so this is 11 over 9 times m square over s. You can write this is k times m square over s, the same thing. So the value of k is 11 over 9 m square over s. And now we have to find r when m equal to 6 and s equal to 1. So you substitute m equal 6 and s equal 1 in this equation. So it will give me this 11 over 9 times m square is 6 square over s equal to 1, right? So let me simplify this. So this is 11 over 9 times this 6 square is 36, and when I put in the lowest term, whatever this is, so okay, 9 on the 9 for the 36 divided by 9 is 4, so 11 times 4 is 44, right? So the value of r is 44, right? The value of r is 44 when m equal to 6 and s equal 1. Thank you.